focus 2 and 3, or days 2 and 3. I'm kind of combining them because it's the same content. This is trig in the coordinate point, so it may seem like it's not connected to angles of rotation, but it is, and we'll maybe see it in a second. This diagram is basically showing how any point in any quadrant is basically the combination of the horizontal amount of units and the vertical amount of units. We already pretty much know that. That's how we graph things. So like if I asked you to graph the point 1, 2, we would have to go in the x direction, because it's x, y. We have to go in the x direction 1, to the right 1, and then in the y direction up 2. And that's exactly how we did it. We went right 1 and up 2. In the same sense, if we had some point x, y, to find it, we'd have to go, right x units and up y units. But what we're doing in this unit is that we're going to have this line right here, and we're going to have to figure out what both of these units are, x and y. So it sounds a little confusing probably, but basically just making triangles and using SOHCAHTOA. All right, so here's the first example. The answers are already given, so you'll see where this is leading, but we're gonna let's already kind of penciled in here. Let the point 3, 4 be a point on the terminal side of theta. So that may sound confusing as well. All that means is here's xy. 3, 4, we could graph that. It would be like 1, 2, 3, and 1, 2, 3, 4. This is the point 3, 4. If it's a terminal side of theta, so really what we just did was we created an angle of rotation. Here's the initial side, and all we did to get up to 3, 4, we had to find the terminal side. It would end at 3, 4. It'd be right there. So our angle theta is created by the initial side and the terminal side. That would be this degree measurement. We don't know exactly what that is yet, but we know that that's where we would put theta, because this point is created. We quite literally counted in the x direction 3 units to the right. So that would be that part of this triangle that I'm about to draw. And then 4 units up in the y direction creates the triangle. And you see that theta is already placed. X and y meet at, horizontal and vertical meet at a 90-degree angle. So we see this triangle that got created by just plotting a point. And I mean, we kind of know that already, because in order to plot the point, we had to move in left, right, up, down directions. It's just that since we're talking about angles of rotation, where we place theta is basically what all of this lesson is about. We're making a triangle. We need to know where theta is. So a couple tips on this is the triangles that we create will always, the hypotenuse will always start at the origin and go out to the point. And we're going to call that R usually. This kind of leads into polar coordinates. Don't need to worry about that, but we'll call this length R, kind of like radius. But that's the hypotenuse. And so again, to create these, one pro tip is that the hypotenuse of the triangle that I create will always start at the origin and go to the point. That is also your terminal side. Your terminal side is your hypotenuse. The other thing the rest of your triangle, the other two sides of your triangle, have to be on the x-axis for one. So that's you're always going to have one leg of this triangle on the x-axis, no matter where it is. And then the other piece, the other leg of the triangle will be vertical, going up. I guess another feature would be your right angle will always sit on the x-axis like this. We'll never have a triangle that's like this, where your right angle's on the y. You won't have that. Okay, anyway. Here's what we know about this triangle. I'll speed this one up. This is 3 units. This was 4 units. So if I wanted to do, cosine, let's say, I would say, here's theta. Cosine of theta is adjacent over hypotenuse. So you would say this is 3 over r. I don't know the length of this. This is where we've avoided it for as long as we can, even though it's really not that bad. It's kind of slick. This is where we need to know Pythagorean's theorem. So it works for all right triangles. The two legs are a and b, and we have the formula a squared plus b squared equals c squared. And we can plug this stuff in. So this would be 3 squared plus 4 squared equals r squared. 9 plus 16 equals r squared. 25 equals r squared. And then you could square both sides and you'd get 5 for r. That's how I know that cosine is 3/5 from theta. Adjacent over hypotenuse is 3 over 5, as we see here. And this was just like day one in Unit 7 triangle trig when we did SOHCAHTOA. All we were doing is trying to figure the exact values of the trig functions. Like the first problems we did, just find the ratio, find the fraction. So sine, you could do it's opposite over hypotenuse, 4/5, and tangent, opposite over adjacent, 4/3. Okay. There's a couple more examples. Now would be an appropriate time to pause it and try this on your own. I'll grant it, this one's probably a little bit more difficult just because we got some negatives. I'm not sure what we're going to do. Okay, so it says let -2, -3 be a point on the terminal side of theta. Find the exact values of the trig functions. Basically, don't get hung up on what it's saying, all this stuff. All we need to do is plot the point. Left 2, down 3. Okay, so that's where my point would be. -2, -3. And to get there, that's where the point is, we would be drawing that line. And that's our hypotenuse. The other tips, I guess, in creating this triangle, to make sure we're creating it correctly, is theta's always got to be placed between the x-axis and our terminal side, or the line that we just drew from the origin to the point. So that means theta is going to be tucked in there. And that kind of also tells you what the side lengths are of our triangle. Another way to think about it is the other legs of the triangle that you're creating. They have to be the directions that you counted to plot the point. Like you went left, and then we went down. Always do the x first. Okay, then. This is your right angle. And we know a lot of stuff about this triangle already. We placed theta at the right spot between the terminal side and the x-axis. We know that this is a -2 and this is a -3. That's kind of misleading. The negatives just simply mean which direction you're going from the origin. They don't actually mean an actual length of a side of a triangle, because you can't have a negative length. So we can think about those as being positive, but they won't matter when we use Pythagoras theorem anyway. Here's what we get. Negative 2 squared plus negative 3 squared equals r squared. This becomes positive. Negative times negative. Negative 3 squared is a positive 9. So this is now 13 gross. And r will be simply square root 13. Okay, so what this means is now we have everything we need to in order to just set up each fraction for sine, cosine, and tangent of theta. So from theta, sine is opposite over hypotenuse. I filled these in. Sine of theta is opposite over hypotenuse. I put negative 3 over square root 13. A couple just points about that. I said a moment ago that the sides of a triangle, if they're the side lengths of a triangle, they can't be negative. You can't have a negative length of something. So the negative is just kind of, I kept in the answer because it becomes important later. So we'll still leave those in. The other thing is when you have a square root as part of your answer, part of a fraction, if it's on the bottom of a fraction, we're supposed to do what they call, whoever they is, rationalizing the denominator. It just means we're not supposed to have an irrational number of square root on the bottom of a fraction. And really, it's just probably never been explained why not, but it makes it easier for estimation purposes. But because it's probably never been explained, if you've ever had to do it, to make sure there's not a square root on the bottom of the fraction, don't worry about it. I'm not going to mess with it. Until we examine why this would be a problem, let's not make it a problem. Cosine adjacent over hypotenuse would be negative 2 over square root 13. And then tangent, negative 3 over negative 2, opposite over adjacent. Since they're both negative, I made them both positive. Okay, here's the last example of these types. And then basically there's a couple more examples that's about what focus 3 is. That's why these lessons are combined. But I'm not going to waste video time going through this. I'll pause the video and then fill it out. So now would be a great time for you to pause it if you want to try it. There you go. All right, and there they are. That's that problem worked out. Again, just a couple points. I know this video is way too long. Theta always has to be between your the terminal side or your hypotenuse, the side of the triangle that you first draw when you plot our point. Goes from the origin to the point right there. That's where 3 negative 5 would be. Theta always has to be between that and the x-axis. That's like the main thing. You got that, you can pretty much draw the rest of your triangle. For instance, if I didn't know that the rest of the triangle was, right there, I only had this terminal side drawn, like from here to here. If I didn't know where theta was supposed to, or if I didn't know where the triangle was supposed to look like, if it was going to attach to the y or the x, 1, it always attaches to the x-axis. But 2, if theta's always got to be between the x-axis and our terminal side, or the line that we drew that goes to the point, then if theta's over here, well, it has to be in my triangle, so the triangle has to be over here. The other thing, I guess, is this is exactly what a reference angle always is. Theta is always a reference angle. And a reference angle, if you can't remember, is the distance, like in degrees, of whatever your angle measurement is to the nearest x-axis. And if you notice, in every single problem, that's what theta is. It's this degree measurement from the terminal side to the nearest x-axis. See this one? From the terminal side to the nearest x-axis. See this one? From the terminal side to the nearest x-axis. They're always, that's always what theta is. All right, the last two. This is where focus 3 starts, and the reason why these are combined lessons because it's identical. It's the exact same concept. It's just now we're going to actually figure out what theta is, which is just, as we remember, it's just using inverse trig. So this is saying find the reference angle created by the point -4, -6. We're doing exactly everything the same. So this is -4, -6. Just plot that point. Negative x direction, and then -6 is -6 down. So it'd be like this point. Okay, we should be somewhat decent at just drawing this now at this point from the origin. And the only really thing I need to remember is that theta, where I place theta, is always going to be between this terminal side and the x-axis, because theta is a reference angle. Okay, so a reference angle would have to be just the distance to the closest, to the nearest x-axis. So that would be like this distance. That's the same angle as that angle. Okay, so we know that's where it is. Then you can draw the rest of the triangle, or you probably could have anyway. There's the x, that's the y, that's the right angle right there. This would be -4, this would be -6. Again, sides of a triangle would always have to be, if it's a length, it would have to be positive, but I'm maintaining the negativity of these numbers to reference later on. No pun. We need to know what the hypotenuse length is. But I guess I would we'll figure out what r is first, but that'll mention something. So -4 squared, -6 squared, those are the legs of the triangle. A squared plus b squared equals c squared. 16 plus 36 is 52. And 52, we can, it's not a perfect square. We square both sides, we get r. Whew, I'm going to say just leave it as square root of 52 for now. However, you may remember from some other classes like geometry, algebra 1, algebra 2, that we can actually reduce this radical. 52 is actually made up of 4 times 13, and 4 is a perfect square. So just a brief reminder, this could be broken up into square root of 4 times square root of 13, because certainly if I multiply those together, I'd get 52, and 4 is a perfect square, so really square root of 4 is 2. So really r is that if we want to simplify it all the way down. The reason why I don't really care about that right now is because 1, not really part of this lesson. 2, technically, if we're just trying to find the angle, I don't really need to know what r is. Why would that be? Dramatic pause. Yeah, it's because I have 2 sides of the triangle. I have the opposite and the adjacent. I could just tan it. I would just set up the equation saying tangent of theta is equal to -6 over -4, which they're both negative, so they're both positive. And 6/4 could be reduced. Doesn't really matter, but I'll do it anyway. Is 3/2. Now, we really haven't done anything different than in the previous problems. We have tangent of theta. We could write sine of theta now, because I did figure out what r is. It would be opposite, so -6 over root 52, or I could do cosine. Theta is -4 over root 52. But we wanted to figure out what the reference angle is. Find the reference angle. That means theta. Find theta. So, well, we know where it is, but like we want to find out what the value is. And in order to do that, we made these trig functions. But if you recall, when you're ever finding an angle that's connected to a trig function, that's when we use the inverse trig function. So, for instance, tangent of theta would be tan inverse of 3/2. And you could do the same thing for either one of these, for the sine or cosine, inverse sine 6 over 52 squared 52 or whatever. And we would get the same degree measurement because they're finding the same angle. It's all theta. So in an event, I have theta being equal to 56.3 degrees. And that's your answer. So it kind of, in focus 3, it may ask you to find sine and cosine, but really it doesn't. Technically, if you're just finding the reference angle, it wouldn't matter. We could just tangent. Once we plot this thing, I have the opposite and the adjacent. I could just use tangent. Okay, so everything's the exact same. We still set up the triangle. Well, the last thing I want to say is if you were to use sine or cosine, those both have one negative in them. It's going to kind of change things for us. So what you'd have to do is you would indeed to figure out what theta is, because theta is just in this triangle. And in a triangle, you can't have negative side lengths. We would have to call them positive side lengths. So if I did like sine of theta is 6 over square root of 52, I could not use a negative 6. And then it would end up the same thing, same way. Theta is sine inverse of 6 over square root of 52. Then this would give you the exact same answer, 56.3 degrees. And similarly, if you did the same thing with cosine, you would use positive 4. It would be cosine inverse positive 4 over the square root of 52. And you would also get 56.3 degrees. Okay, there's one last example. And this is the first problem of the Focus 3 assignment. So you'll notice on the next page here, do only the odds. Skip number 20 on Focus 2. That one, don't even worry about it. But it says do only the odds. That's because we're going to be skipping this even one anyway. However, the whole idea is just that because we combined both Focus 2 and 3 in one day, you should pause this and try this problem. I'm not going to stop the video and fill it all in, at least not right away, just in case you want a couple steps completed. Okay, ready, go. Okay, we're going to find the reference angle. 2, -5. So over 2, and then -5 is down here. I can kind of be a little bit imperfect where I'm putting this. As long as I label the side lengths what they are, it doesn't really matter. I didn't have to count it. I just know where it's going to be somewhat. I went right 2, down 5. Terminal side right there. The angle has to be between the terminal side that is true and the x-axis. So theta has to be right there. And that tells me, oh, well, the triangle's got to be over here somewhere. And there's my right angle. I know the side lengths to -5, though maybe we won't use the negative. And again, I mean, I can scroll down here quick and see, but it's problem number 42. 42, it is asking for sine, cosine, and tangent, not just the angle. However, again, if I just wanted theta, I would use tangent because we already have all the information we need. But since we're supposed to write sine and cosine, it's a real quick Pythagorean's theorem. 2 squared plus -5 squared is r squared. You can do this. Okay. 3 trig functions. All right, so I'll stop the video here, or I'll pause it and then start recording once to finish it off, but you should be able to do the rest. Okay, one moment. There. I wrote sine, cosine, and tangent, each of the trig functions, and you could choose, if you have all 3 of them, you could choose which one you want. You would not, there would be no need to do all 3 of them because you'd be finding the exact same value 3 times. They all accomplish the same task to figure out what theta is if you use the inverse trig function. So I chose to do sine. Sine's my fave. So I just made it non-negative, and I got 5 over square root of 29 then, and so theta was 68.2. Just if you're curious, if you leave the negative in there, what it did is it knows that if I did sine of -5 over square root of 29, I would get a negative 68.2. And that's not totally incorrect. I mean, if you think about it, because this reference angle is 68.2, well, negative 68.2 would start at the initial side and go right there. It'd be the same angle. So technically that works. Anyway, good luck. Let me know what's confusing and ask questions. Thanks. Enjoy.